recording now. So again, 3-5 is about working backwards. Last time I would give you some kind of equation like so, and then would ask, okay, what's the slope, or what's my y-intercept, or hey, graph this. So then you could say, there's my y-intercept. So at the 0.04, we have a dot. My slope is 3/1. So if we wanted to, we could go up 3 and over 1, or down 3 and back 1. And there's my line. Okay. Tonight, 3-5, you're going to be given the line, or they're going to give you the slope and a point, or they're going to give you 2 points, and you're going to need to come up with the equation. So it's all about working backwards to what we did in 3-3 and 3-4. So if I just give you a random line and said, hey, write the equation. Okay, this is actually one of the easier problems. Okay, writing the equation all stems from slope-intercept form. Okay, if you remember slope-intercept form, that's actually the way I graphed this one. Okay, slope-intercept form is based off of your slope and your y-intercept, which is where we cross the y-axis. So if they give you the line, okay, to find slope, we just have to count. And in this case, it looks like we go down 3 and then left 3. So down 3 would be a -3. Left 3 would also be a -3. So that gives me a slope of 1. And we cross the y-intercept at the 0.03. So my y-intercept is 3. So I can just plug that information in. So y equals 1x plus 3. So if they draw the line, okay, it's really easy. Find the slope, find the y-intercept, plug that information in. Now, if they don't draw the line, they will do one of 2 other pieces of information. They will say something to the effect of, okay, write the equation of the line with a slope of 1/2 going through the point 4-3. I'll let that focus. Okay, so they're going to give us some information, but it's not the actual graph. Now, you could draw this graph if you wanted, and then you could do the same thing. Or we can do this by algebra. So drawing the graph is really only good if you have graph paper to do so, or if they're dealing with really small points. For example, if they gave me a slope of 1/2, but they gave me the point like 100, -200, okay, I don't want to try and find the y-intercept by graphing it out and counting it and trying to draw the line. I'm too likely to make a mistake, or it's all zoomed way out, so that's no good. So we can still do this algebraically. So if we've got our slope-intercept form, technically they gave us 3 of the 4 pieces of information. Okay, the obvious one is the slope. If they give you the slope, that goes where m is. But remember, this ordered pair is a coordinate where this number is your x and this number is your y. So we can replace x and y with the x and y from our coordinate. So if y is 3, that goes there. If x is 4, that goes there. And then the b is the only thing we don't know. I got to be careful because my b's look like 6s. These are b's. So we can solve for b. So 3 equals 1/2 of 4. 1/2 times 4 is 2. Subtract 2 from both sides. And b is 1. Now, the problem is Most people are really good at algebra in the fact that we're used to solving for a variable. Once we know what a variable is, they just circle around it and call it good. Remember, I want an actual equation. So I should end up with something in this format. So in this case, again, they gave us the slope, so that goes where the m goes. And we just solved for b, so that goes where b goes. And then this is my answer. Now, I don't remember if my math lab does this or not. I can tell you for the test, this is 100% always going to be okay. I am perfectly fine with you always leaving the equation in slope-intercept form. If my math lab asks for what we call standard form, standard form is just another way to write this equation. Standard form has the x's and y's on the same side of the equation and no fractions. So x is going to move over to the other side. So if it's being added here, we need to subtract it. So it would be -1/2 x plus y equals 1. And then to get rid of the fraction, we're going to multiply everything by a -2. So that gives me 1x minus 2y equals -2. This is the same equation, just in what we call standard form. So again, I'm never going to ask you for standard form. I am perfectly okay with slope-intercept form. And I just can't remember if my math lab asks for it or not. Heck, even if it does, just email me and be like, Mr. Nail, I typed in this equation. It said standard form, so I left it like this. Can I have the points back? And I'll go back and look and see if you did it right, and I can give you the points back on that. So anyway, if that was too complicated, I'm not worried about it. If you can get to this, this is the best form for graphing anyway. Slope-intercept form makes the most sense. So that's what I would actually prefer you to use. All right. Another thing they can ask you to do, well, tell you what, I'll do another example of that. So let's say, again, we want to write an equation with a slope of -1/3 going through the point 5/7. So this is going to be an ugly one. We're going to end up with fractions in our answer, but it's still going to work. All the same stuff. Y equals mx plus b. Plug your stuff in. So my y is 7. M is -1/3. X is 5. So the only thing we don't know is our v. Multiply -1/3 times 5 is a -5/3. Add 5/3 to both sides. And let's see, 7 plus 1 2/3, it'd be 8 2/3, or 8.6 repeating, or 26/3. I don't care how you write that. Then just remember, we need to rewrite our equation. So y equals mx plus b, put m where it goes. It's a -1/3. Put b where it goes. That's that 8 2/3. Or again, 26/3 or 8.6 repeating. But remember, when I want an equation, that's the answer I'm looking for. Okay, it needs to be some equation. Now, like I said, there are a couple of different things they can ask for. And the last thing they may ask for when they want you to write an equation is write an equation going through these 2 points. Okay, these are kind of the trickiest ones in my mind, just because you've got the most things going on, which gives you more chances to mess something up. So in order to fill our information in, the first thing we need to know is, what's my slope? Okay, if I'm going to fill in y equals mx plus b, I got to know what my slope is. Given 2 points, I don't know it, but I can figure it out. Remember, slope is y minus y over x minus x. So my y's are 4 and 3, my x's are 1 and 5. It doesn't matter which order you do this in, but 4 minus 3 is 1. 1 minus 5 is -4. That gives me a slope of -1/4. So if they give you 2 coordinates, step 1 is to find the slope, y minus y over x minus x. Okay. Next, we still do everything off of that y equals mx plus b. The tricky thing here is, okay, y and x, which one do I use, the 1, 4 or the 5, 3?
Does it matter?
It doesn't matter. Okay, good call. You can use either one. The big thing is just pick one. Okay, so I'm going to use the 1 and the 4, and I'm going to use my slope. So we got to use our slope and then just pick one of the points. And I'll show you, actually, it wouldn't matter if we did the 5 and the 3. We should get the same thing. So again, y is 4, m is -1/4, x is 1, b we don't know. So if I add 1/4 both sides, b is 4 1/4, or 4.25, or 17/4. Okay. There's your equation. I'm going to do the same problem, but I'm going to say, what if we would have picked the 5, 3? So if we multiply -1/4 times 5, we get a -5/4. Add that 5/4 to both sides. 3 plus 1 1/4 is still 4 1/4. So we still get the same b value regardless of which coordinate we choose. So it doesn't matter, just pick one.
So when you multiply, like if you have a fraction, can you multiply it so it only affects the top number?
Yeah, because basically this is like saying 5/1. So if we take 1/4 times 5/1, you just multiply tops and bottoms. Yeah, so if you take a fraction times a whole number, it only goes to the top.
Okay.
And if you're not sure, your calculator will do that. You can just take 1/4 times 5. All right. Here's a problem that tends to give people trouble, but if you recognize it, it's not difficult. It's really easy. So if they give you something like, write an equation through the point 1, 4 with a slope that is undefined, when there is no slope, people run into trouble because they try to use slope intercept form, y equals mx plus b. The problem is, can we plug in undefined? No, okay, undefined isn't a number, okay, it just tells you something that doesn't exist. So remember, what kind of slope is undefined? What kind of line is that?
Vertical?
That's a vertical line. So remember, slope undefined simply tells you you're talking about a vertical line. And remember, a vertical line is always an x equals equation. So if I want the equation of a vertical line, it's always going to be x equals something. Well, and what do we know x has to equal?
1.
X has to equal 1 in this case. So if you ever get a slope of undefined, remember that's a vertical line that is an x equals equation. So you just write x equals and then whatever the heck x needs to be. Slope of 0 is a y equals, and you can do that just as easy, but if the y is 0, or if the slope is 0, you can actually plug that into your slope intercept form and do it just like we did. No big deal. The undefined one is tricky because you can't. It's like people, like they brain freeze. It's like, I don't know what to do. Slope is undefined. So just remember, undefined slope is still a vertical line that's an x equals equation. A similar problem would be something to the effect of write the equation, going through the points, 2, 4, and 2, -7, something like that. So we go to find our slope, y minus y over x minus x. 4 plus 7 is 11. 2 minus 2 is 0. Oh no, 0 is on the bottom. Again, that's undefined. Okay, undefined slope is a vertical line, so this is going to be an x equals. And what do you know? X has to equal 2. So write an equation of a vertical line is easy if you recognize it. If you get this undefined and you don't remember what to do with it, that's when people run into trouble.
So would you recommend if we like don't remember what we're supposed to do, just kind of try to solve it? If like we come out to 0, then we're okay.
Well, just once you recognize, like, again, if your slope is undefined, but you try plugging everything back into y equals mx plus b, okay, you're going to plug 4, undefined, and 2, and b. But wait a minute, like, how do I do undefined times anything? Like, I mean, if you try plugging your stuff in, this doesn't make sense.
Yeah.
It'd be like having infinity in an equation somewhere. It's like, infinity isn't a number. I can't do anything with that. So when you start having concepts mixed in, it's like, this doesn't make sense. So that's when you just got to remember that an undefined slope is a vertical line. The reason it doesn't make sense is you're trying to put y in an equation that doesn't have a y. So that's why this doesn't make sense.
Well, I'm just saying, like, if we don't, like, when it asks, like, write an equation.
Yep.
Like the 2, 4 to 2, -7. Could we solve that and then realize that it's undefined? Like.
Yeah, I mean, when you go to find your slope, that's when you're going to see it's undefined. But the one thing that I would pay attention to is, regardless of the points, whoa, that went way out of focus. Come on, catch up. Sorry about that. Hopefully that didn't make everybody sick. Again, if you're looking at 2 coordinates, if they have points that are the same, okay, obviously x has to equal whatever the heck this is, because those didn't change. Okay. Or the other way around, let's say we had 5, -2, and so this one's going to be x equals 1. There's your equation. Or 4, -2. Okay. If you have 2 pieces of the coordinate that are the same, okay, that tells you this is a y equals -2 situation. Now, they may also combine the equation problem with something we did last time. So this is the last thing they'll do as far as 3, 5 is concerned. So write an equation through the point 1, 1, perpendicular to y equals 1/2 x plus 3. Okay, y equals mx plus b. We want to go through this point. So my y is 1 and my x is 1. And then this information here, this perpendicular to 1/2 x plus 3, the only thing I need this for is for the slope. Okay, so the slope of this line is the 1/2. And what does a perpendicular slope tell me I got to do with it? Perpendicular means I got to change the sign and I gotta flip it. So a perpendicular line to 1/2 will have a slope of negative 2/1. So the 1/2 flips and it goes from positive to negative. So again, all of this information here is just so I know what slope to use to find my equation.
And when, so, okay, if you wanna, instead of having to use like the fraction, if you have like the one on bottom, you can make it a whole number, correct?
Right, and that's what I did. So negative 2/1, I just put in -2.
Wait, can you repeat that question she asked?
Yeah, so she said, basically, if you don't want to leave it as a fraction, anything over 1 is just a whole number. And that's kind of what I did without saying it. So negative 2/1 is the same as the -2 that I plugged in there. So a whole number over 1 is just the whole number. Does that make sense?
Yes, thank you.
Yep. So 3-5 is all about writing the equation. So the big thing I want to stress is when it's all said and done, make sure you rewrite the equation. A lot of people correctly solve for B, or they solve for that y-intercept, but then they stop. It's like, oh, look, I know what B is. And they circle it and then they're done. Okay, remember, go back and plug your slope and your y-intercept back in. I want to end up with an equation. If they say write the equation, make sure you end up with an equation. All right, now we're going to completely switch gears. And I'm going to talk about 3-6. So 3-6 is all about graphing non-linear functions. There are a ton of non-linear functions. My math lab focuses on 3. Your test, I will narrow it down to 2. I won't tell you which one I'm choosing, but it's going to be one or the other. So just as a heads up. So my math lab focuses on absolute value graphs, x squared graphs, and square root graphs. And the good news is the way they graph is the same. The only difference is the shape. Okay. An absolute value is going to graph in a hard V. There will be a special point here called the vertex. And then from the vertex, you're going to go up or down at a constant slope, like so. I'll do 2 examples of that. An x squared graph makes what's called a parabola. It also has a vertex, but it's more curved. This is constant. It's going to go at a straight line. This one is curved. It actually starts going way more vertical. Okay. And then a square root graph looks like that. Now, the good news is with my math lab, as long as you know the vertex and then like one other point, so like the vertex and one other point, or like the vertex and one other point, it'll draw the rest of the graph for you. So the biggest piece of information is figuring out where this point is. That point starts your graph. And we're going to do it based off of parameter shifts. So for example, for an absolute value equation, it looks like this. That's y equals, that's an A, then the absolute value bars, x minus h plus k. So If you are adding or subtracting inside of the absolute value, that is going to shift your vertex to the left or to the right. If you see a plus, it actually shifts to the left, which is backwards. Okay, normally on a graph, negatives are to the left, positives are to the right. Okay, in terms of the shift though, if you see a plus, that will actually shift you to the left, that number of units. If you see a minus, that's going to shift you to the right. This K value is going to shift your vertex up or down. This one actually moves like it's supposed to. If you see a plus, it's going to shift the whole thing up. If you see a minus, it's going to shift the whole thing down. These are the big pieces of information. Because again, once you find that vertex, the rest of it's just finding another point that works, which you could kind of do by plug and chug if you wanted. But anyway, the next thing I want to talk about is this A value that affects the stretch or the shrink. The bigger this number, the skinnier this V gets. The smaller the value, the fatter or wider the V gets. And if A is negative, that's going to flip the whole thing over. So I'm going to do a couple examples of an absolute value graph. Also remember, if you're not sure and you want to practice, Desmos. Desmos is that graphing utility, DESMOS.com. Okay, go there, type your stuff in, it'll graph it for you. You can figure it out. But anyway, if I told you to graph y equals the absolute value of x minus 2 plus 3. All right, normally the vertex starts at 0, 0. So whenever I talk about shifting or moving up and down or left and right, it's from 0, 0. So this number, the number inside the absolute value, again, is going to move you left or right. The fact that it was a negative tells you that this is going to shift to the right this many units. So my vertex is going to go right 2 units. This number moves you up or down. Remember, if it's a positive, it's going to shift up. So that plus 3 is going to move my vertex up 3 units. So instead of being at 0, 0, I'm going to shift right 2, up 3. This is my new vertex. If you don't see a number out in front here, it's an automatic 1. This number affects the slope of the graph. So basically you're going to go up 1 and over 1, up 1 and over 1. So it's kind of like the slope. So 1 is 1 over 1. There you go. And the left side just matches it. Okay. Same game. Let's say I want to graph y equals negative 1/3, absolute value of x plus 3. This number is my left and right shift. Remember, if it's a plus, it's actually going to shift left. So it's backwards to what you would think. So we're going to go left 3 units. The number out here affects your up and down. If you don't see a number being added, it's just like saying plus 0. So that means you're not going to shift up or down. You're just going to stay on the x axis. So that's my new vertex. Okay. Again, the number here, A, is like the slope of your V. So rise 1, run 3, but negative. So you're going to come down 1, back 3. So that's going to be my V. And again, the other side just matches that. So down 1 over 3. So there again are lots of nonlinear graphs. We're going to focus on 3 of these. Again, on your test, I'm only going to mess with absolute value or an x squared. I'm not going to do the square root one, but my math lab does, so we'll talk about that. Okay, like I said, while the shape changes, the parameter changes do not. So I'm going to go back. So the absolute value function, okay, the number in front, if it's negative, it flips it, but this affects your stretch or your shrink. This number moves you left and right. This number moves you up and down. The x squared function looks like this, which, wait a minute, that looks very familiar. Okay, it's the same. It also has the same parameter changes. So guess what? A affects the stretch or the shrink. If it's negative, it's going to flip it over. This number is left or right. Again, same direction. So if you see a plus, it goes left. If you see a minus, it goes right. This number moves it up and down. Again, positive goes up, negative goes down. So the only difference is what the graph actually looks like. The shifting and stuff is all the same. An absolute value will give you a straight lined V, and x squared is going to give you a rounded parabola. Okay, again, so let's do an example. So if we wanted to sketch y equals x plus 1 squared minus 2. Again, inside the parentheses here is going to shift left or right. This one moves backwards. The fact that it's a plus is actually going to shift this to the left 1 unit. This minus 2 is going to shift the whole thing down. There's my vertex. Now, specifically graphing a parabola is a little more tricky. All you need to know is if this number is not here, or if it's a 1, your next point is going to go over 1 and up 1. And then you just draw a rounded curve going through it. And the left side is going to match it. If there's a number, go over 1 and up that many numbers, and then draw a rounded graph. But again, for my math lab, all you need is your vertex and 1 point, and it'll sketch it for you, and you don't have to worry about it. I'll do one with a number in front. So let's say I wanted to sketch y equals -3 x squared plus 2. Okay, the number inside moves you left and right. There isn't one, so we're not going left or right. This number is going to move me up 2. So there's my vertex. Like I said, the standard normally goes, if you don't see a number or if you see a 1, we're going to go over 1 and up 1. When you see this -3, go over 1, down 3, and that's the only point you need. And then you're going to draw a rounded curve through that point. So you would get this downward facing, very skinny parabola. And again, these are the 2 shapes that I kind of want you to focus on. On your test, the nonlinear graph will be one of these. It will either be an absolute value or it will be a parabola. And again, the only difference is whether it's curved or straight line. Okay, absolute value, straight line, x squared, curved. And really, again, a couple of points, draw the rounded curve. That's all I'm looking for. That justifies being in the right location. If we needed more specific than that, we would be able to use some sort of graphing utility. Okay, now, like I said, my math lab does talk about the square root function. And again, it's more of the same. Stretch, shrink, flip, left and right, up and down. Again, the only difference is a square root function only goes in one direction from this point. So if I were going to sketch one of these, sometimes they'll put the +1 in front, like you'll see 1 plus square root of x minus 3. So this doesn't have to be at the back. It typically is, but it doesn't have to be. But anyway, your shifts are the same. So this -3 is going to shift to the right 3 units. This +1 is going to shift up 1 unit. Whatever the number here is, you're going to go up that many and over 1. In this case, up 1 and over 1. And my graph would look something like that. I would love to show you kind of how to do this on my math lab, but the last time I tried that, it did not work out well. And I went back and looked at the video and you couldn't see crap. The screen was like pure blank. So it doesn't do me a whole lot of good to walk you through it because you're just listening to me talk anyway. So the big thing I want to tell you is when you click on my math lab and you click on the graph, it's going to give you some options down there at the bottom. Just make sure you pick the right ones and it should be obvious. There'll be a V, there'll be a U, okay, and there'll be like an absolute value graph. So to make sure you graph the right one, just make sure you grab the right shape. And it's basically based off of whatever the function is. As long as you click the right button, it will give you the right graph. Just if you just automatically click the straight line one, the linear graph, and you go to graph, it's going to draw a straight line. So it's like, no, I want this to curve. Okay, so that's all based off of, so like on my math lab, you're going to click and there's going to be a gray box down here with some options. Like one will be the straight line, one will be the V, one will be the U. They may give you a cubic function. I don't know. They can give you a bunch of different things, but just grab the one that looks like whatever the heck you want to grab. And as long as you get the vertex or that main starting point, as long as you get this point in the right location and one other point, it'll sketch the graph for you. So don't stress needing to know where all of the points are. And again, you can use Desmos, DESMOS.com to check anything. You can literally type any equation in, it'll graph it. Pretty cool. All right. Now we're going to circle all the way back around to 3-2. 3-2 is really kind of a standalone unit because while everything else really ties together nicely with just Y's and X's, 3-2 is related to functions and function notation. Okay. Anytime you have two variables, it's usually X and Y. This is referred to as a relation because the X and the Y relate to each other. As you change one, it changes the other. Okay. A function is a very specific relation where each element of the domain has a distinct and separate element from the range, which doesn't mean anything right now, but I'm basically just going to tell you that ultimately the domain cannot repeat. Oh, wow. That's terrible handwriting. That says the domain cannot repeat. If the domain repeats, then it is not a function. It is just a relation. So first off, the domain. The domain is your set of inputs. In terms of a graph, it is your x's. Any x values, whatever you input into the function, is an element of the domain. So the domain is strictly worried about your x values, which means the range is the opposite of that. The range is your outputs or your y values. And again, whether or not something is a function is to whether or not the domain repeats. Now, there are a couple of different ways they're going to present the relations. The easiest ones are when they give you just a collection of ordered pairs. Okay, this is a relation. They're going to give you a collection of ordered pairs, and they're going to ask, okay, what is the domain of this relation? And again, your domain is simply the set of x's. So all you're looking at is those x values. So the domain is the collection of the inputs. So remember, ordered pairs always go x comma y. So your domains are your x's. That in this case is the 1 and the 3 and the 5. If they ask you for the range, that's the outputs. That's your y. So that would be the 2 and the 4 and the 6. We put them in the squiggly brackets because it's the set of those numbers. And then go ahead.
I was gonna say, when we're writing this out, is it the same kind of order of operations where you need to keep the, like if you use 1 first in the x, then you need to put the 2 first in the range since.
Okay, no. Order doesn't matter.
Okay.
I will typically write them from least to greatest, but order doesn't matter. They can be all out of order, and like you could do 1, 3, 5, and you could do 6, 2, 4. Like the order doesn't matter. So it's just a collection of those items. Good question. And then whether or not this is a function, okay, again, just look at your domains. As long as your domains are all different, so we got 1, 3, and 5, none of those are repeated, then yes, this is an example of a function. I'll do another one. All right, so I just did another collection of coordinates. So 1, 3, 1, 5, 2, 3, 3, -7. Okay, your domain is again the set of x's. If a number repeats, you don't need to write it twice. So you don't have a domain of 1 and 1 and 2 and 3. Okay, once a number is in the domain, it's already in there. There's no need to write it twice. So in this case, your domain is 1 and 2 and 3. Same. Range is 3 and 5 and -7. There's no need to write the 3 twice. Once you've written the 3, it's already in the set. So there you go. And again, order doesn't matter. Some people would put the -7 first because it's the smallest. I just go from left to right. So it's all the same. Okay. And then is this a function? No. And it's simply based off of the domains repeating. Whether or not the range repeats doesn't matter. The range could actually be all the same number and you could still have a function. But if the domain repeats, so the fact that I've got a 1 going to a 3 and a 1 going to a 5, that 1 is repeated, then this is not a function. Another way they can give you a relation, this is pretty typical too. They'll just give you like two boxes or circles or domes or whatever, and then they're going to do something like that. This is just simply another way of writing it. Basically, this is saying like 3, 1, 4, 2, -7, 2, 5, 1. So this input goes to this output. So just like I have 5, 6 here as an ordered pair, okay, this 5 drawing an arrow to the 1 is basically like saying 5, 1. 5's my input, 1's my output. Same thing. 3 is my input, 1 is my output. So for this particular function, my domain would be 3, 4, -7, and 5. My range is just the 1 and the 2. And then this one is a function. Drawing the arrows, okay, you can tell if it repeats because if there was more than one arrow coming off. So each number having only one arrow clearly makes it a function. If, just for instance, let's say this 3 also had an arrow going to the 2. Now is it a function?
No.
No, it is not. Okay, so your 3 goes to the 1 and your 3 goes to the 2. So if you see 2 arrows or more coming off of the same number, then that would no longer be a function. So that tells you whether or not that number is repeating.
On the test, do you need us to write out domain and range for you to see, or does that matter?
I don't need to see it. So like, I'll actually probably give you a box that'll say the domain, and then I'll just have like a line for you to fill in. So I'm not worried about you writing the word domain, just something that signifies what the domain is valid. That's going to be good enough. And like I said, on my math lab, it specifically says, what is the domain? And then it's just looking for these numbers in the brackets. Now, this is the hardest one. At least this is the one that most people have the most trouble with. When they draw a graph. All right, there are a couple of things that make this tricky. Okay, first off, we're not talking about just a set number of points. Okay, graphs by nature, because you see these arrows, they're going forever. Plus, they include every point in between. So if I said this is 1 and this is 2, 3, 4, okay, this solid line represents every single possible input between these two numbers, which we talked about the fact that there's an infinite number of numbers between the numbers. Okay. So when you're looking at a graph, we have to kind of change the way we think about domain, and we're no longer going to list each individual point, because I can't list 0.1, 0.111, 0.123. Anyway, I'm not going to list all those possible decimal points in between. So for domain of a graph, we're going to use that interval notation. Remember that interval notation, it's read from something to something. In this case, how far, well, domain is your input. So domain, think x-axis, think left and right, okay? How far left does this graph go? Okay, that arrow says this graph is going to keep going forever, right? So every possible x value, forever small, will give you a y value. It's going to start getting really low, but you're still always going to get some y value. So it doesn't matter how far you go left on the x-axis, you're always going to get some y value. Likewise, it doesn't matter how far right you go on the x-axis, you're always going to get some y value. So your domain goes from negative infinity to positive infinity. It hits all of those numbers. Your range is the up and down content, okay? It's the Y axis. Which Y values get hit, okay? And every Y value positively and every Y value negatively are gonna get hit. So again, when you do interval notation, make sure it reads from small to big. We read it from bottom to top. If you have those flip-flopped in order, okay, that's wrong. If you try putting positive infinity and then negative infinity, it's gonna count it wrong. Okay, it's gotta read from small to big. Domain we read from left to right. Now, whether or not it's a function is really easy. There's a thing called the vertical line test. If you can draw a vertical line anywhere on the graph and it's only going to hit once, then that means that input only has one output. So as long as you can draw vertical lines and it only hits once, then it is a function. And we're going to do a few examples of these because this is kind of tricky. Again, I'm only going to put one of these on the test, but there's like 4 or 5 in my math lab and they pick some really tricky ones. So just be aware of that. All right. So if we've got a graph, it's kind of like a half circle. Okay. Again, domain, you read from left to right. What is the farthest left? Where's my farthest left X value?
1.
At 1. What is my farthest right value? 5. The fact that these dots are colored in, okay, the solid line means those are actually included, so that's why we use the brackets. We use parentheses because infinity always gets parentheses. But remember, just like we did with the interval notation on the linear inequalities on the graph, closed dots or a closed line is the brackets because they're included. Okay, range, again, we read from bottom to top. What is my lowest Y value? 0. And then what's my tallest Y value?
3.
Looks like 3. So again, domain reads from left to right, range reads from bottom to top. And my functions only get hit once, or my domains only get hit one time. So this is an example of a function.
Okay, I'm confused. How you get the 0?
Okay, so again, range reads from bottom to top. So think of the Y. So don't think of these numbers down here, the 1, 2, 3, 4, 5. When we're talking range, we're looking at these. So my Y value of 0 is the lowest that my graph goes to. And it goes all the way up to the 3.
Okay.
So like domain and range, like if you could draw a box around this graph, it's kind of like what are the parameters of the box? So this is the left side, this is the right side, this is the bottom, and this is the top. So if you can kind of think of it that way. Like when you see these 1, 2, 3, 4, 5 on the bottom, that messes with people. Remember, range, you're looking at the vertical aspect of it. Does that kind of make sense?
Right, thank you.
Yeah. Like I said, this is the trickiest concept and tends to get people the most. Number one, the notation is a little bit goofy. Number two, it's just kind of a hard concept to get. But like I said, the good news is there's only one of these on the test. So you just got to be ready for that and do the best you can. I'm going to do 2 more examples. And then if you're done with me, you guys can check out. If you have more questions, I'll stick around and answer them. Actually, I want to say this goes forever. I don't want it to keep going forever that way. Basically, this pattern is going to keep going. Okay, so it's gonna look something kind of like that. Wow, that is really crappy handwriting. I was looking down, it didn't look too terrible. I look on the screen, it's like, new. Anyway, so domain, range, is this a function? So again, domain reads from left to right. So what is my furthest left?
Would it be the -2?
Goes all the way to -2. Nothing beyond this gets hit. Like the graph doesn't come over here anywhere. It continually bounces back and forth between -2 and +2. So your domain is going to go from -2 to +2, and it never goes beyond that. It constantly kind of works its way back and forth. Now range goes from bottom to top. How far down does this graph go? Forever. So we say -infinity. And then how far up? +infinity. Now this one, is it a function?
Yes.
No, because if you draw your vertical line,
Oh.
it's going to hit more than once. That means an x value of -1 gets all of these different y values. So this domain gets repeated over and over and over again. So if that vertical line hits more than once, then it is not a function.
So, okay, so I got a question.
I got an answer.
So if it's, the domain is for infinity on both sides, and the range is like a -2 and a 2,
Okay.
would that still be a no, or would that be a yes?
Okay, so I think what she's asking, so let me just see if I get this right. So I had a question about what if we kind of flip-flop this graph? So what if it bounced back and forth this way?
Yeah,
Okay, so say we went from +1 to -1 this way. And again, I'm going to draw arrows, but basically just pretend like this keeps going. Okay, so our domain would be from -infinity to +infinity. Whoops, I'm sorry. I'm putting the picture back on the screen now. Okay, so again, if we turn the graph kind of sideways, so now we've got a wave kind of going up and down. Your domain goes forever left and right. Your range is going to bounce back and forth from -1 to +1. And again, whether or not it's a function is that vertical line test. If I draw a vertical line anywhere, how many times am I going to hit? Just once. So this one would be
okay.
a function.
So the function is practically like any vertical line, correct?
If your vertical line hits more than once, then it is not a function. All right, I'm going to do one more.
So now you want to bring that up some.
Yep. All right, I get it. This is kind of a goofy graph, but it's going to illustrate kind of what I want to talk about. All right, it gets real easy to kind of look at what's going on with the graph specifically. Again, just kind of take your mind off of that and just look direction. So if we're talking left and right and up and down. So your domain is your left and right. How far left does this graph go? Again, that arrow pointing down here tells us this is going to keep going forever and ever and ever and ever. So this graph is going to go forever negatively. Then it's going to go all the way to the 0, and then from 0 we go down, and then we go back up. So again, just looking left and right, okay, we go forever small and we go forever big. So we hit everything in between. So your domain is from -infinity to +infinity.
So the way I would look at this, and I know it's wrong, but because you have 2 points,
Yep.
wouldn't that? Oh, that's on the Y. Never mind. I
Yep.
see what's going
Yeah,
on.
I know right where you're going, and I'm going to talk about that here in just a second. But again, so with domain, we're just talking left and right. Okay, so don't focus on the up and down. we're left and right. So again, which X values get hit? This X value gives me a Y value down here. This one gives me one here, this one here, this one here. So every X value is going to get hit. Likewise, every X value gives me a good Y value. So every X gets hit. Okay. Range up and down, not every Y gets hit. For example, I'm going to kind of show this in a different color, but if you look, this space in between here has no numbers in it, right? So your range can't cover this area. Basically, your range says from forever small all the way up to 0. And then from 3 to infinity. So again, think of it in terms of up and down. So don't think about the fact that this actually on the axis. So if you're looking at just the y-axis, okay, it goes up to 0, and then this one goes up to 5 or whatever, then down to 3, and then back up. You don't have to explain that. We're just saying what y values get hit. If we're looking at this, the y value at 3 gets hit, and then every y value above 3 gets hit. Same thing, everything y value below 0 gets hit. The only ones that don't, there's nothing going on in this range. So we have a gap between 0 and 3, and this is how you write that gap. So from negative infinity to 0, and this is the union for the symbol for the union or the or, and then from 3 on. Now also really tricky, is this a function?
No.
No, okay. There's one spot. If you draw right on the y-axis, guess what? You hit here and you hit here. So this one spot, if we draw a vertical line, we're actually going to have 2 points. At x is 0, y can be 0, or y could be 5. So because that one hits twice, this is not a function. So if this little piece wasn't here, if it was just this line, if it was just this line, we would be fine. But because the x of 0 gets hit twice, that's what makes this not a function. Okay, and that basically finishes 3.2. I waited to cover it last because it's kind of the trickiest, and it doesn't really match anything else we did as far as the function goes. Oh, shoot, there's one other thing I want to talk about real quick. I got 5 minutes left in class. If they give you something like this, okay, these are just function notations. Okay, and then if it tells you to evaluate or say what is f of 3, all that's telling you to do is plug this x into the x of the f function. So f of x is x squared plus 1. So then f of 3 means 3 squared plus 1. So 3 squared is 9, 9 plus 1 is 10. So again, what this is saying is if you've got an input of 3, then you have an output of 10. So if they tell you to evaluate a function, they're going to give you something like f of -1. Okay, again, that means to plug -1 into the x of the f function. So that's going to be a -1 squared plus 1. -1 squared is 1, plus 1 is 2. So again, that would be the point -1, 2. Input -1, output 2. And if they change the letter, so let's say we wanted the g of 3, that just tells you to plug it into the g function. So this means plug 3 in for x. 3 times 3 is 9, 9 plus 1, this one's also 10. Or if they gave you g of 2, that means plug 2 in. 3 times 2 is 6, plus 1 is 7. So if they ask you to evaluate the function, they're not asking you to do anything difficult. Just plug that number into the correct function, order of operations, figure out what your number is. Oh, 10, not 0. Silly goose. All right, we ran right up to class time. So I tried to talk fast. We had to cover 3 sections. Remember, your test is next week. If you want to test during class time, it's going to be happening here at the Lebanon site at normal class time. Otherwise, you're going to need to make an appointment at your testing center. I will send out an email, I hope, to remind you of that, to make your appointment. I would call ahead just to make sure that they're ready for you. If you just show up, they're going to be like, we weren't planning on this to happen, because they've got to know ahead of time. So they have somebody there, they have their copies made. So call ahead of time. Make sure you have your appointment set. I should have your tests at your testing site by Monday morning. So whatever time is convenient for you, you need to make an appointment and call so that you can get your test taken at some point next week. So say you take your test on Monday, you do not need to log into the Zoom. There will be no Zoom on Thursday night because we're just testing. So I'm not going to make you sit here and watch us take a test or anything like that. So next week, basically, as long as you take your test, you will be considered present. So just make sure you take your test sometime next week. Also, I went through and I've been looking at my math lab. Some of you are doing a great job of staying on top of your homework, and you have pretty much it all turned in up to what we've covered. Great job. Some of you, I'm going to pretend like you're just waiting until right before the test and you're going to use it to study, and that would be fine. I'm encouraging you, do not wait until the last possible second. I promise technology is wonderful until you need it. And then at that point, that's when it's going to throw snake eyes. Like 10 minutes before you need to turn this in and it's got to be done, that your computer's going to crash, your power is going to cut out, your internet's going to go down. Okay. You want to be ahead of this. I get it. Homework is not worth a ton of the points. Like the test is the most important thing. The test carries a lot of the weight of your grade, but the homework is important. It's enough to kind of bail you out. I've seen a number of people do all of the homework, get C's on the test. They end up getting a B in the course. Okay. So the homework is worth doing. It's great practice. So make sure you're doing it. Don't neglect the homework. The homework is all on that My Math Lab. Okay. Go in there, click on the My Homework button. I know it's a lot of problems, but make sure you're going through and doing that homework. You want to get all the points possible. Get your points. Anyway, that's all I got. Test is next week, so no actual class, no Zoom. If you want to take the test here at Lebanon, I will be here Thursday night from 7 to 8:15. Otherwise, make an appointment at your testing center and you're good to go. If you have no questions for me, you're free to go. If you have a question, I'm going to stick around for just a little bit longer, but enjoy your night. I have an answer.
So going back to the beginning about the domain and ranges and finding out if the domain repeats.
Yep.
If you have, say you have a domain of 1 and a domain of -1 and a domain of 3.
Okay.
Does that considered repeating?
Nope.
Or is -1
exactly
technically its own number?
That
Okay.
could be like 1 and 1 and 3, or -1 and -1 and 3. But
Okay.
1 and -1 are different. Okay. All right. Then I'm going to go ahead and end this so it'll start, and then I'll push the video to Canvas here in just a little bit. Thanks, guys.